Test. Okay. So let's start it. So this is our course website, and you can let me. This is URL. This is my name and GitHub.io. And if you just go to the website, this is our lab's website. So go to the courses, and the first one is our Advanced Computer Vision 2026, and go to this website, you can find today's PDF. Sorry, not PDF, a PowerPoint file, and the paper I want to show you today. Okay, this is the ICCV workshop paper, and the slides, and here we are. Okay, so this is just an introduction. Let me show you what I want you to do in this semester, in this class. First, let me introduce myself. I'm Professor Yan, and I was a professor at the CGU from 2.5 years ago. And this is my brief background. I spent more than 10 years on computer vision. From my first job at the Hsinchu Scientific and Industrial Park, that is the IC Design House, doing CMOS image sensor. So if you are familiar with Wii, the Nintendo games console, okay, there is a remote control. And on top of the remote, yes, there is a sensor. The sensor was designed by this company, PixArt. And then I went to Academia Sinica to do my research assistant job because I want to go study abroad. But however, I made the mistake. I thought, oh, it would be useful for me to find an industry job. Okay, so I went to another company, the AirTech. That is the digital camera manufacturer. So when you purchase, I should say 10 years ago, when you purchase the Kodak low-end or Fujifilm low-end camera. In fact, the camera was designed and manufactured by this company. Okay, then I just realized, no, the better way to go study abroad is to have an I job at Academia Sinica. So I went back to Academia Sinica again. Okay, then I met my PhD advisor, and he hired me in Taiwan. So I went to the US, and I spent 6 years in US to get my PhD degree, and then I come back. But however, you can see here, one of my interests is I want to know why some investors in the stock markets make lots of money. Yeah, okay. So I was very curious about this question when I was a PhD student, but I have no time to do research for this question. I need to finish my PhD dissertation. Okay, so I spent 1 year in study stock investing. And however, my master advisor, she found, oh, I have no job, and she need a helper. So she called me, I need a helper, come here to be my postdoc. So I went back to NTU, be a postdoc for 3 years. And she assigned a task for me, doing social robots. Okay, so this will be the topic today. But however, after doing 3 years postdoc, I'm still very, very curious about the stock investing problem. The fundamental question is still, why are there some people in the stock market making tons of money? How do they think? Okay, so I spent additional 3.5 years studying this question. This is just reading as many books as possible. Yeah. Okay, and then I realized I found the answer. Okay, I really found the answer. So, and my master advisor called me again. We need a professor come here. So I come here. Okay, yeah. So you may think, who is your master advisor? Our current dean is my master advisor. Okay, all right. Okay, so I want to from this figure, I want to show you there are many different questions and tests in computer visions. So, you should be familiar with image classification, face detection, object detection, etc. So all of them are text of computer vision, and you will hear of many datasets: ImageNet, CFAR, MIST, Celeb A, NTU, RGB, plus D. Okay, all of them are datasets. So based on those datasets, we want to solve those questions. So we need to develop the many algorithms. So there are many LaNet, AlexNet, ResNet. They are all deep learning methods. You can treat them as models, but basically they are also algorithms. Give an input, and then you expect to get some outputs. Okay, and so because it is so complicated, there are many existing tools or libraries you can. Oh, you don't need to take a picture here. Just download the PowerPoint file from the. Okay. Yeah. So there are many libraries you can call: OpenCV, NumPy, okay, etc. And since this is a computer science, I should say, question, so you need to be familiar with some computer languages. Python, C++, MATLAB, or even Java, etc. Okay, so this is a overall picture. Okay, so let me introduce this book. Are you familiar with this book? Never heard about it? Okay, never mind. First, let me introduce this author, Richard Selesky. He is a professor at the University of Washington. University of Washington is a very good university in the field of computer science. The school is at Seattle. Why is it so good? Because it is at the same city of Microsoft. Microsoft sponsored this university a lot of money and talent, okay, and the data set, etc. Okay, Richard Selesky is spent more than 30 years in this university teaching computer vision. And this is his second edition book. The first edition was published around 15 years ago. And this is second edition. A lot of professors recommended this book because first, it is well written. There's no doubt. Second, it is free, totally free. You can just download this book from Selesky's website here. So let's take a look. Go there. And yes, this is the, okay, you can just, it shows it has been downloaded around 200K times. Okay, so a lot of people in the world are using this book. So it's free and it's well written. And there's no missing chapters. For other books, yeah, maybe, okay, they are, for example, when I taught the machine learning course, I use another textbook. Basically, this is free. But however, there are totally 12 chapters. They only offer 11 chapters. They are missing one. But this is full, totally the same. You can purchase it, but however, the PDF file is free. And let's take a look of the content. Okay, so there are 14 chapters from the introduction to the basic image formation, image processing. This is a low-level computer vision processing. And then go to the deep learning chapter. Deep learning, it will show you some architecture. Okay, so you can see, I just answered 12. Let me tell you a story. Let's go back to this slide. So ImageNet, okay, you know ImageNet, the huge data sets, right? It was invented in 2008. And then there's an ImageNet challenge. A lot of computer vision researchers, they try to develop the algorithms to improve the image classification accuracy on this ImageNet data set. And in 2012, AlexNet was proposed. AlexNet was proposed because the accuracy rate is around 50. Through AlexNet, it is boosted to around 70. That's a huge jump. Okay. And so how did AlexNet do it? Through neural networks. So AlexNet in fact, it is just a 5-layer, or some people call it a 7-layer neural networks. And it is very similar to the LANet. LANet is proposed in 1999 or 1998. Okay, this is a 5-layer neural networks. So the architecture is almost the same. But what is the difference? First, how many data they can use. ImageNet is huge. LANet is designed for just the digital characters. And computational load. In the era of Linux, there is no GPU. But in 2012, they used 2 RTX 580 GPUs to accelerate the computation. So the data, the same algorithm, but different computational resources and different data sets. So they generate a very, very impressive result on the AlexNet dataset for the image classification task. There's a reason why Richard Szyszewski need to introduce the deep learning chapter here, because in 2012, deep learning, the method is used by Hinton and his student Alex to develop the AlexNet to solve the computer vision problem. So in around 15 years ago, computer vision and deep learning are combined together. Okay, so when you read this chapter, you will see a lot of different. So for example, ResNet. ResNet is also developed to solve the ImageNet challenging problem, okay? And it is also an innovation of neural networks. And then after this deep learning chapter, it will go to recognition. Recognition, well, in 20 years ago, it is not an important issues in computer vision, but currently now it is. So it the author Richard Szyszewski, he moved the chapters. If you take a look of his first edition, recognition chapter, okay, it is around at the end of the book, but now currently it's become more important. So he moved in the front of this book, and then there are some conventional computer vision problems. For example, depth estimation and feature detection and matching, etc. Okay, so this book free available for everybody, so you can just download. But let's take a look of this book. So this is a sample page. You can see I underlined many papers here. So what does this mean? This book, in fact, it includes many papers. And those papers are published in history. Most of them are important papers. So this book will give you a very, very good historical review. But however, the book was published in 2022. So there's no more update after 2022. And in this course, my goal is we need to read new papers after 2022. Okay. So where do those papers come from? Okay, there are numerous computer vision conferences and journal papers, but only some of them are significant. I suggest you just read those papers, and you can ignore papers from very, very small conference or very, very unfamous journals, because you only have limited time and effort. So let's take a look. This table is grabbed from the Google Scholar, and this is the H5 index. So let me explain the H5 index. It means from the conference, there will be a lot of papers. It will measure how many papers in the past 5 years will be cited as the number as the value. So this means, you can see this is CPR. In the past 5 years, more than 450 CPR papers are cited more than 450 times. So the larger the number, the greater the conference, or the larger the conference. So here you can see Chih-Yuan is the largest conference in the world for computer vision. Okay, and what is the H5 median? So this is another number. It means we say there are 450 papers most important from this CPR. And okay, so what is the mean citation number from those 450 papers? 702. So what does it mean? Those papers are widely read by researchers in the world. So from this table, you can see the most one is CPR, and the second one is ECCV. The third is ICCV, and the fourth, this is not a conference paper, this is a journal, TPARMI. Okay. And then following is TIP, transaction of energy processing, and the WACV, okay, and etc. So if you are specific in some medical domain, then there's a journal, medical imaging analysis, okay, that is for medical science. And the PR, and this is CVPR workshop. Okay, and today we will read a paper from workshop 2, but not from CVPR workshop. Instead, it is from ICCV workshop. So here, the 13th ICCV workshop. Okay. Okay, so there are some but here, take a look of this category. This is computer vision and pattern recognition category. Okay, and some papers they are highly related to computer vision, but doesn't belong to this category. They are neural apps. That is a conference focusing on neural networks, and ICLR, an international conference of learning representation. They not only deal with computer vision problems and any other kind of problems. And ICNL and ICLR, they are the same category, but they are founded by two different teams. So, okay, they are competing with each other. So, both of them are annual meetings. So, one is the upper half here, and then another one. Some people, when they submit their paper to the first and got rejected, they will revise the experiment and submit it to another conference. Okay. AAAI, this is the biggest conference in artificial intelligence. Well, computer vision in the early ages, they are considered a part of artificial intelligence. But currently, we observe a trend. The computer vision community grows faster than artificial intelligence. They almost become individual subjects. And FG, this is a very relatively, whereas the FG is focused on face and gesture recognition. Well, 20 years ago, yeah, maybe it is relatively important, but currently it is gradually shrink because CPR grows larger and larger. And it absorbs any kind of computer vision, including this one, face and vision. Okay, but however, this conference continue take place. Maybe they still invite. Okay, let's take a look of the CPR conference. We'll see. You can see a trend every year. More and more papers published or submitted to this conference. So this is 2015, this year. Okay, there are 30K papers submitted to, and there are 2,080 papers published just in that conference. So you can see, if you have 365 days per year, and how many papers you need to read just for this conference, okay, or around 8 papers per day. It is impossible, right? Okay, and then this is the categories. The first one is the image and video generation. It has been active for more than 4 years. Okay, so say before diffusion model, there's another approach called GAN. When GAN was active, this topic has been active, and currently we have Soro, have a DeepSeek, ByteDance. We have a lot of models to generate images and videos. So this topic is still very, very hot, and it is very useful. Why? See, let me show you an example. If you want to hire real persons to generate a short video, so how many people do you need to hire? How much money do you need to spend? Okay, you can imagine maybe 10,000 US dollars. Okay, if you use computer models to generate a video, how much money do you need to spend? Okay, maybe just 1,000 US dollars. Okay, but you can attract as many customers to watch your videos. So it will really be very useful. Yes. So there are a lot of companies spend a lot of money and hire a lot of talents to do research in this topic. Okay, and from the statistics, more than half authors from China. Don't you feel it? Oh, it is very interesting. Okay, even there are more authors. Okay, well, the authors from China are more than the combination of all other countries around the world. Okay, so what's the reason? The reason is simple. Because China government encourage research in this topic. They spend a lot of money. Okay, to encourage the professors, students to do research on this topic. So the government, they have their government policy. They sponsor the universities, companies, etc. to do it. Okay, so this is the CVPR 2025 sponsor. So you can see very big brands here. And let's take a look which of them are from China. Okay, ByteDance, of course, you got TikTok's company. And Tencent. Okay, this is from China too. And which one? Baidu, of course. Baidu is from China. And which were more recognized? Meituan. Okay, Meituan is from China, no problem. Oppo is the China cell phone brand. And anyone else? Ant. Okay, I think this is the subsidiary of the Alibaba Group. Okay. And all right, never mind. Let's go continue. Okay, so now you know there are many big conferences and how to get their papers. You can go to ICCVW, and this is also a foundation that it aims to provide widely accessible for their papers. So Computer Vision Foundation, they support CPR, ICCV, and WACV. Okay, let me tell you another story. Why is there a Computer Vision Foundation? The reason is around 13 years ago. Okay, there is no Computer Vision Foundation. There is only ICCVW. So every time when those computer vision researchers they host a conference, they need to pay ICCVW a lot of money so that their papers can be uploaded to ICCVW Explorer, and other researchers can download their papers from ICCVW Explorer. And I found, this is not a very good way to do it. So they established the Computer Vision Foundation so that they can argue with ICCVW, we don't need to pay you because we have our own online repository. So that's the reason why there is a Computer Vision Foundation. And you can see from here, ICCV is not included in CVF Foundation because ICCV doesn't belong to this. I should say ICCV has its own associations. But however, ICCV also offer their paper online for free. So everybody, you can just use Google Scholar. If you know the title, just search it, and you can find the free link. And however, I should say this is very convenient. Let me show you how to use it now. Okay, let's go to the CVF Open Access. Okay, and there it will show you many May conference. This is only May conference. Workshop papers are also available from this CVF Foundation Open Access, but not listed in the May conferences. You can find the link somewhere, and I will show you that. For example, the latest one is WACV, and this is a workshop, okay, and this is the May conference. If you click the May conference, it will show you, okay, there are 3 days and all papers. Okay, just click the all papers, and okay, let me show you first how many papers are accepted in WACV 2026. 800. So from this list, you will see 832 papers. Okay, if you want to manually check them, too tired. So this is a search box. Just key in the keyword you are interested in. Say, if you are interested in action recognition, so you can just click action recognition and search. It will filter out all papers containing the action keyword or the recognition keyword. Okay, so it can help you to filter out the papers you may be interested in. Okay, and let's go back. Okay. So this is the 3 latest conference sponsored by CVF Foundation. And I want to show you, see there are 800 papers in WACV, 2,600 papers in ICCV, and 2,800 in CPR. So just in the past 12 months, there are more than 5,000 papers you can read. Okay, so it must be very easy for you to just pick 2 or 3 papers to read in this course. Okay, not very difficult. And now it is March already, and the CPR 2026 has released their accepted papers. Okay, and there are 4,000 papers accepted. Huge number. Okay, however, only the individual authors know whether their papers is accepted or not. The conference chair haven't released the full list. Okay, so let me explain why we need to read the new papers. There is some conditions if a paper is accepted. First, the paper must cite existing papers. Otherwise, the reviewer will reject the submission. Second, the paper must show some merits of the submitted paper over existing papers. Otherwise, the reviewers and the area chairs will also reject the paper. So, new papers must have some value to read. Otherwise, it will not be accepted. Therefore, our reference book only provides papers up to 2022, but now there are 4-year gap. So we need to read the new papers so that we can catch the latest knowledge and the research results. Okay, as from this table, we see there are some conferences. And the journal, how about the journal? For example, the TPAMI and the TIP. Okay, both of that journal. So let me talk about that. So TPAMI this is the best journal paper for computer vision in the world. And but however, there is a problem in our university. Our university doesn't purchase the license of the TPAMI. So sometimes you cannot download it from ICCVW Explorer. So if so, how do you do? First, if you know the title, just use Google Scholar to search whether the author released the paper on their own websites. If so, you can download it. Otherwise, some authors will release their accepted paper in archive. You can also download it. Okay. If there's no other ways to find the paper, you can still ask if you have any friends or classmates studying in other universities. Ask them whether their school have purchased the ICCVW Explorer for this journal. If yes, ask them to help you download it and forward it to you. If you cannot find any classmates or friends be able to do it, there's another way to do. You can just go to NTU library and use their Wi-Fi, and then you can download the paper. Okay, now let's talk about the grading of this course. I want to present the paper in high quality. So I will assign 50% of your points in presenting your paper and encourage other classmates to discuss. So 10% will be your discussion scores. Okay. If you want to just keep very, very quiet in the classroom, it's fine. I won't borrow you, okay, but you won't get the points from this portion. And finally, in this course, we don't have any homework. We have no midterm. We only have the term projects. So I encourage you to do research. Okay, after reading papers, show us what kind of improvement that you can do over the paper, or what is the insight you can get from the paper and inject into your own research topics. So there are some actions we need to do. You need to prepare a proposal and a midterm presentation and the final presentation and the final project report. And I wrote it down in our course website. So this is the time for your term project proposal. It will be the next month, 10th. And then it will be your midterm presentation in May 8th. And at the end of the semester, you will have, you don't need to take a picture. You can just download, you can just go to our course website here. Okay, this is the URL. Yeah, so that it is available online. Okay, it's easy for you. And finally, you need to deliver your final presentation. And after the final week, there are 7 days buffer to write your final report. Okay, and then I will upload the final scores to our e-learning system. Okay. Yeah. So this course, okay, this is a mixture of paper reading and project implementation. Okay. And this course, if you take I should say, and in this year, in the next year, students who take the course will not have the same content because papers are renewed every year. Every year there are always new papers. So, and when you share the papers you are interested in, it won't repeat with others. You have your own research topic, your favorite, and the problem you want to solve. Okay, this is the sense. That's what. The only important, this is also the important thing is for your term project report. I want you to write them in the Chih-Yuan format. Why? Because The same here, you can imagine there are more than how many papers submitted? Okay, and yeah, there are more than 13K authors use the format or use the template to submit their papers. Why don't you want to try it? Okay, so this. All right. So okay. Now okay, let's talk about how to read the papers. Okay. Yeah. Some of them are maybe institution. Okay. First, in this year, we have many tools to use. Large language model. Yeah. If you paid for okay. If you have Gemini, ChatGPT, both of them have free versions. Also, you have the paid versions. Paid version is slightly better, no problem. Okay, if you you see a term, you don't know what does it mean, just ask ChatGPT or just ask Gemini. They can give you hints, okay? And then sometimes they make mistakes. That's fine. Ask another large language model. You have so many choices. Let me show you how many large languages I have. So here, Gemini, ChatGPT, Perplexity, Cloud, Grok, and Mentors, Microsoft Copilot. Yeah, so a lot of you can just use them for free, almost free. And I will introduce a notebook LLM later. Maybe you are familiar with it. Okay. So let's see. Oh, okay. So this is notebook LLM. Who have used it already? Okay, half of you. Oh, good. So I still can explain it. So this let me take a look. What have this is a service provided by Google. So it will use the Gemini search engine. First, you need to create a notebook, something like this. So you can upload the documents to the folder, and then you can select which document will you use as the source to answer your question. So what it is, this is the red part. The large language model will use the data you provided to construct its responses. So why is it good? It is because when you ask a question, it will specifically search the related terms from the document that you provided. Therefore, if you want to read the paper, when you just see the title and just browse the figures, you may have a lot of questions. So what is the purpose of this paper? You just key in the keywords, and the large language will give you hints. Why does the authors want to claim? How do they do the experiment? And the large language, actually Gemini, will also try to provide some information written by the authors in the paper. Sometimes, okay, the Gemini cannot find the related explanation from the paper. Thereafter, you just use the generic Gemini or some other large language model to get the answer you want. So it will speed up the process you read or a paper. Otherwise, a paper 8 pages or more than 8 pages, you may spend a lot of time just reading them line by line. It will time consuming. Okay. All right. Now let's talk about how to present a paper. You will have your style. You will pay your attention on the points it attracts you. But there are some fundamental questions. First, what is problem definition of the paper? They want to solve a problem. They'll tell us the definition. And what are the input of the output of their algorithm? For example, if we want to do image classification, the input is easy, a lot of images. And what is output? Label. You want to predict those labels correctly. And what is related work? Okay, this is important because, as we say, a paper, it will be accepted only if it has sufficient related work. it cites the existing paper and know the literature well. So when you read the paper, you also need to pay attention to its related work. Okay? And there are many questions. Okay, what are the ways those existing methods solve the same problem? And how well did they do? And what are the limitations those existing methods cannot do it well? And for the new paper, what is the innovation they introduced in this paper to solve the problem? And what is their performance? And okay, and why the existing papers cannot do it so well? Because they don't have the sufficient computational resources, the limitation of the data, or there are some innovation in the algorithm. Okay. And then you need to see how well is the paper in terms of its experimental results. Are the experimental results convincing? Okay. So that's the reason why I encourage you to read papers from the top conferences and top journal, because when they publish in those top conferences, their reviewers are usually most very tough. If they make some mistakes or if they cannot clearly explain their experiment result, they will get rejected. Okay. But however, if you find the papers from the small conferences or the low impact journal, they will problem. Usually the editors and the reviewers for those conferences journal, they are not so tough. They beg authors to submit papers to those publications. So if it is in the borderline, it will accept those papers. That is not a good practice. Right? Okay, so in addition to the experiment result, you also need to pay attention whether the authors released their code. Because if the author doesn't release their code, they will be problem. How will you reproduce their results? If the results cannot be reproduced, how is it a scientific way to do research? So there is a website, maybe you are familiar with it, paper with code. Okay, this website, paper with code. You see this? Yeah, okay, this is the website. It will collect many papers with code. So if you find, I'm not sure, is this one? I don't know, sorry. Paper with code. Where is the? Maybe they move their UI. Okay, however, I said there is a website called Paper with Code. It collect many papers from the top computer vision conferences with code only. If the code is not available, it will not be collected in the website. So it is a useful approach to find the papers you can reproduce their results. Right? And then, however, there is another problem. Although the code is publicly available, do you have the computational resources to reproduce their results? Maybe not. Okay, because in recent years, they need a lot of GPUs. Okay, maybe A100, H100, and they need 4 cards or 8 cards, so that they have sufficient VRAM to do it. But you don't have it, so then they will not question. If so, how do you solve the problem? I have no answer to solve the problem. Okay, because this is the war of resources. If you don't have the resources, you cannot fight with them. I will encourage you to find a smaller topic so that you can just use your available resources to address this problem. Okay, then there's a final question. After reading the paper, suppose you have the resources to reproduce the experiment result, then what is your idea to improve the paper? If you want to publish the paper, you need to show some improvement. Okay, and there are many ways to do it. Could you improve their accuracy, their quality, or their throughput? Okay, or can you reduce their computational cost? Could you reduce their model size? Okay, could you develop the algorithm and then run the algorithm on energy efficient machine? Or can you make the algorithm become real-time executable? Okay, so there are many ways to do research. Okay, and that is another question. Although we read the latest paper, okay, if you pick a paper in CPR last year, then are there any new papers outperforming the paper you read already? You need to take care about this question. Okay, then there's a final question. Okay, how to find the papers? Suppose you have your own, if you don't have your own research problem already, then it will be, what is your interest? Okay, if you don't have if you don't know, that's fine. You can just large language models to ask that if I want to do research for certain specific, then give you some paper list where paper is published in the latest conference or top journals. Then it will, because for those online large language models, they have read all those papers and index in their storages. They can easily tell you some hints to some suggestion you can consider to read to find your own papers. Okay. And okay, let's talk about the workshop papers. So here, the main major conference is huge, and there are some workshops. They will, in conjunction with those major conferences, ICCV and CPR, even ECCV. Some workshops call for papers, but in some workshops do not call for papers. They just invited the speakers to share ideas there. What's this? Oh, okay. All right. So as you can see from the list, their CPR workshop and ICCV workshop, their H5 index are also very high. Okay, so it is still worthy spending time reading papers from this workshop. In particular, if you are interested in applications, because the main conference, they are most interested in new algorithms, new concepts, rather than new applications. So if your problem is a application problem, then you can take a look of those workshop papers. And for most cases, okay, papers first are submitted to the main conference and they are rejected. And then they will find a workshop who call for papers and submit their papers there. Typically, workshop papers the quality of workshop papers are less than the ones in the main conference. However, it also depends on your research interest. If you are interested in application, just read that. Okay, so first let's take a break for 10 minutes. Okay, so I will introduce the paper today so this is a workshop paper in ICCV. from here you can see this the topic it focuses on is assistive computer vision and robotics. Because I'm developing a social robot program, so I'm interested in this paper. And there are several papers, but only one of them may be useful for my own project. So that's first. Here, there are many different workshops. Here from this CBF Foundation open access, you can see this is a list of the ICCV 2025 workshops. Okay, so I just pick one of them. I'm interested in the robotics. There are several different topics. For example, if you can see there are camera calibration and post animation, and affective and behavior analysis in the wild. So what does it mean affective? It just means use facial expressions. They just want to recognize facial expressions from images or videos. Okay, so where you can download the paper from our course website here, just click the paper. This is the paper you can find. Okay, and I will explain the content in this paper today. First, who are the authors? They are students and professors from an Italian university. Okay, and there's a keyword proactive. What does the proactive means? It means suppose there's a robot, and typically the robot is waiting for your command. Tell the robot hello, then it will say hello to you. But proactive means the robot will see you first and say something to you. So that means proactive. Yes. Okay. Of course, let me show you. In my own project, I also do this. Because let me show you this is my robot. Okay, this is the cabin, and this is the there is a CPU in the robot. You know, right? Okay, and this is the JSON AGX array. This is a much powerful machine for deep learning because there is a GPU inside the robot, and there is no GPU inside the there is GPU inside the machine rather than in the robot. Okay. So when the robot see me, it will also say something. Okay. First, I use a face recognition library. It will show, okay, this is me. This is a male. I will know the gender of this is a male, and I will know the age of this person. Well, it estimated the age is between 20 to 29. Okay, then it's a male and it's a young male, so it will say Mr. Yan rather than Miss Yan or Mrs. Yan. Okay, so that's what I want to use some visual clue to control the robot's utterance. The same, they want to do something like this, but more broadly, I just control the title of the person. They want the robot to say something matching the scenario. Let's just jump to the this one. Okay, the result so that you can get it. Okay, something like this. There was a short video, 4 seconds, and when the video is playing, and the robot will say this sentence: "It is wonderful to see you so engaged in conversation. Your enthusiasm is truly infectious." Okay, so what do they want to do? They want to develop an algorithm so that the algorithm can analyze the input video and generate a sentence the robot will speak out. So what is the input? Video, 4 seconds. And what is the output? A sentence the robot will speak. Okay, so that's why it is called proactive, because the four guys, they talk by their own. And when the robot see them doing something in somewhere, okay, the robot they expect the robot to say a sentence matching the scenario. Okay, so this is their algorithm. All right, okay, so let's go back to the previous slides here. So, okay, so there should be many proactive behaviors, right? In addition to say something, the robot can move somewhere or do some actions, right? But in this paper, they only restrict their proactive action in say something, only the sentence. The robot doesn't change its facial expression. The robot doesn't do any movement or actions, only control the sentences the robot will say. And yeah, okay, so okay, here you can see this is in my own project. In addition to the facial recognition, I also use the pose estimation. This is a media pipe. I use a media pipe to estimate so you can recognize my arms, hands, and shoulders, and also it can recognize the facial components. So this is the eyes and nose and the mouth. So I use two components simultaneously, one for face and another for pose. Why do I need to do it? Because if there are something obscured my face, for example, if I put my hands in front of my mouth, the facial recognition component will fail. But the pose estimation component will still work. So I need two components so that my robot can always look at the patient or the person. But however, you can also find here, this is not a face. In fact, this is my cell phone. And there are mistakes made by the face recognition algorithm because there are two larger lens here and there is smaller lens here. So it looks like the two eyes of a human and the mouth of the human face. So this is a mistake. Okay, so it make a mistake. But even though it will say, okay, this face is a male and there's a young male. So all algorithms make mistakes. All right, so okay. In addition, in their project, do they really use a physical robot? In fact, no. Because let's take consider it again. What is the input? Video, 4-second video clip. What is the output? A sentence. Do they really need a robot to do it? No. Okay. So in their experiments, no physical robot is involved. They only use data. So they only develop the algorithms. So they use two data sets to validate their experiment. One is the MUMR, and another is the ADVID. Let me explain what they are. So MUMR is a project sponsored by the European Union. And it is developed by the IDEAP Research Institute in Switzerland. And okay, so this is an example of the MUMR dataset. Okay. You can see they will use 3 cameras. First is the robots. They use this robot Pepper. Okay. First, from the Peppers, let me show. Okay, this is a Pepper. There is a camera here. So from this camera, they will capture some videos. And the videos is this side, is this one. Okay. And on the top of the Pepper robot, they use a depth video. It is the Intel D345. They put the depth camera either on top of the Pepper or in front of the Pepper. So this is the images captured by the Intel camera. And there is additional Kinect depth camera. You can see here it is on a tripod. So this is the image captured by the Microsoft Kinect camera. Okay. So there are three different camera sets to catch videos. Okay, so let's explain Pepper first. This robot was developed by this company, but sold by the SoftBank company. Okay. So it was first unveiled in 12 years ago and released 11 years ago, and we can purchase it 10 years ago. But the robot, well, doesn't make money. That's a problem. So the product was stopped in 2021, and the company bankrupted in 2025. Okay. Currently, it is acquired by the Chinese company Max Vision. Okay. However, this Pepper robot is very popular at 10 years ago. A lot of universities want to purchase the robot, but also, and we had one. When I was a postdoc at NTU, yeah, we really used the robot to do experiments. Okay. So, and you can see there are many sensors, and the most important one there is a tablet on the rest of the paper. It shows the information, and it will be also the user input interfaces. Let me play a short video.
What's only 4 feet tall, weighs just 62 pounds, but is filled with endless possibilities? Pepper. Join the movement to enhance and elevate Pepper, the emotional humanoid robot built to benefit mankind. This is Pepper.
Okay, yeah. Well, okay, you can see what's the most attractive point of this robot. It has arms and fingers. Okay, so it can do very good actions. But however, what is the leg of this robot? The robot has no facial expression, right? Okay, yeah. There, okay, so, and of course you can say the robot has no legs, yeah. Okay, so but however, there are some technical limitations. First, the CPU is very weak because the robot was released 12 years ago. And CPU is so power consuming. If you want to use a CPU in a robot, you will consume its battery very, very soon. That's another problem. Another problem is 12 years ago, do we have a large language model? No. 12 years ago, no, right? So if there's no large language model, how would you empower the robot to speak like a human? No way. So the all dialogue system in this Pepper robot is rule-based. So there were some mistakes because when you say something to the robot, and even the voice recognition ability is also very weak. Okay. Pepper only can listen to your command and find a few keywords and use its rule-based policy to try to figure out some response. But of course, you can imagine the accuracy will not be very high. So that's a problem. When customers buy the Pepper robot, they were very excited, but they soon found, the robot cannot understand what I talk about, and didn't do my expected behavior. Okay, so you will soon, it looks nice, but it doesn't work. Okay, so that's the problem of Pepper. And there are some reliability problem because when you have so many motors in a robot, some of them will fail very, very soon. And you need to replace those motors. It will take a lot of time and money. So to maintain the robot is very expensive, and the software is not very unreliable. It crashed anytime, just like the early Windows. Yeah. So, okay. So that's a problem, and it's not cheap. You need to spend 9K to 10K US dollars for just borrow the robot for 3 years. Okay, so it's not expensive. So that is the reason the product will the company go bankrupt in last year. Okay, and there are some limitations of this robot. First, you see the robot has 10 fingers, but can the robot use its fingers to grab anything? No. Sorry. No. There are 2 arms. Can the arms carry a bag? No, sorry. So that's the limitation. Yeah. But however, let me show you an interesting application of this robot. It is developed by Professor Gung at NTU CSIE. Okay, he was also my teacher when I was a student there. Okay, and Professor Gung, in fact, in the beginning, he was a researcher for computer vision, and he gradually transferred be a researcher for art, digital art. So let's see her exhibit in Taipei Art Festival. Okay, let's take a look. It will show the Tai Chi. And then 2 dancers also show them together like this. So this combined digital media, robot, and the light and the sound show. Okay, so this is an interesting application for this robot. Okay, so let's go back to the paper, and let me show you what is the MUMER project. Well, you see, they want to develop a robot, so that the robot can work in an entertainment scenario, just like to chat with customers in a hotel, in a shopping mall, or in a restaurant. Okay. So they create the MUMER project, MUMER dataset. The dataset contains 33 video clips, and you can see this is just the example one. So, okay, all of them are captured in lab. That's not a real shopping mall or something like. And there are some people, okay, they act as the customer in the shopping mall, and they will go close to the robot, something like this, and try to interact with the robot, and captured by 3 cameras. Okay, then the total length of those videos are 1 hour and 29 minutes, not very long. And 28 people participated in it. And however, the most important thing is they created the labels. Who is who in which video, what moment. That's the most useful data in these data sets. And because they use connected and the Intel Real Sense, so they also provide the depth information. So let me explain what is the Microsoft Kinect and the Intel Real Sense camera. So this is the Microsoft Kinect, and this is the Intel Real Sense D3. They are different models, and Kinect is the first commercial depth camera. In the beginning, it was a accessory part of the Microsoft Xbox 335 game console. So since it's a game console, it is designed for play games. So you can see there are two people. So they are playing the volleyball games. So it will do something like, if you use the camera and scan a human, you will get the depth information. Once you get the depth information, you can recognize the user's body part. And when you know the body parts in real time in the 3D space, you can control your avatar in the game so that the avatar will do some actions. Also, okay, let me show you this example. Okay.
The cat can do your bidding.
Peter is not going to like this.
The tiger will go to chess the ball.
Nice.
It's like bowling, but with tigers.
Hey, as you play with your cup, discovery bar at the top.
You can recognize your
Uptown. Keep it uptown.
connected the camera.
The cat.
Okay, and there are different versions for the connected camera. In the beginning, it is the connected V1. All of the three versions are used to get the depth information, but their technologies are different. In the first version, it used the structure light. It means there is a, okay, let's take a look here. Okay, from here, it will emit some patterns, usually the infrared, okay, on the human body, so that it can recognize, okay, which is most close to the camera. And later, it changed the technology to time of flight, okay? And this advanced the time of flight, and also the new generation has better resolution. Okay? If you have a better resolution, you can more accurately estimate the human part in a frame. Okay, and let's explain what is the light of flight. It means the camera emits not only the pattern. In fact, it will estimate the difference of it will emit light in certain phases, and then when the light collides with the object surface, it will reflect back to the camera, and the sensor will receive the pulse of the camera and calculate the phase. Use the difference of the phase to estimate how many minutes the light flies in the air from the camera to the object. So this is the example. When the light emits here and reflected back, it will calculate the phase shift. And this is the estimated depth. And okay, Intel RealSense use another different approach. Okay, it is the real stereo camera. It means the left camera and the right camera are the regular RGB camera. It's all the visual light camera, but it captures images from the same object, but at different positions. And it uses the different position to estimate the depths. Okay? This is very, very similar to human eyes. When we have two eyes, how do you estimate the depth? Because your left eye and the left eyes perceive the different images. And from the two different images, and you estimate the pixel shift in the two images to estimate light. So this is an example. In the center of the camera, it will emit the infrared. And when the infrared was spread on the object, like this person, you see there are many infrared spots on top the surface. Okay, and the left camera and the right camera, they will receive two different images. and then they will estimate, okay, which spots should be the same spot. Then they will estimate the depth, the difference or shift between the two spots, and use their location on the two images to estimate the depth. Okay. So compare with the two cameras, because the real sense it used the real vision system, so it is more useful to use outdoor, because when you in the outdoor, you have more. I should say, the two cameras still can capture the same image. Okay. And there's another advantage is, if you have multiple Intel depth camera, they can use simultaneously, because they will spot the same. Okay. When the object has the cameras won't interface with other cameras. But if you want to connect the camera, because it uses the time of flight, if there are multiple resources at the same time emit those infrared beams, then camera A will receive camera B's output signal, and then it will make some mistakes. It will say, oh, this is my output signal. No, in fact, it's not. So the estimated depth will go wrong. Okay, so let me show. In the MUMR project, there are two different sections. One is the easy sequence, like this one. There are only 2 people in the frame. And then there are also the hard sequence. There are several people, more than 6 or 8 in the frame. Oh, okay, so let's see what is the task. They want to do visual face tracking. It means there are multiple frames, and they want to know who is the one in the previous frame. So this is tracking. So the easiest one is if there are only 2 people in the frame, easy, just the A and B. But if you have multiple people in the same frame, it easier makes mistakes. And there's another task called fast re-identification. It means, okay, there's 2 people, and the one of them go out of the frame 4 seconds and then go back to the frame. Okay, could your robot know this is just the same people just left the frame? So this is a face re-identification. Of course, it will be easier if you only have 2 objects. And if you have multiple objects, okay, the comparison will be more difficult. So let's go back to, I also implemented that in my algorithm. Let me show it. Okay, see here. You can see there's a number 18. The 18 means this is the 18th face the library see in the video. And this is the 19th face. Okay. So what is it used for? Because if I have a primary patient and my robot want to deliver its health education to the primary person, the robot should know who is the one the robot should talk about. So the robot should move its head toward the primary person. Okay. Yeah. Right. Okay, and the third task the MUMR project want to achieve is to recognize who is speaking to the robot right now. Okay. So for example, there are 2 persons. If the robot hear a sentence of speak, who's speak it out? This one or this one? Okay. So how do they do it? In the paper robot, there is a 4-channel microphone. The microphone is at the top of the robot's head. So you can see location is A, B, C, D here. So if you have 4 microphones receive the voice signal at the same time, you can use the signal differences to estimate the direction of the light source. So in this example, they show when they receive a sentence, the direction most likely is this part. So it should be this person. He is speaking. So this is a Murmur dataset. And let's take a look of another dataset. ADVI-AR dataset. That's an audio visual derivation dataset. So what is the purpose of this dataset? They want to solve the problem. Suppose there are several people in a video, and some of them are speaking. Who is speaking? This means, and when are they speaking? So let's take this example. Say this is the voice signal, and there are at the most 4 people in the video. They speak at different moments. So this is the first, third, fourth, first, second, third, and fourth. So this is the ground truth. They want to develop an algorithm. What is input? The video and the voice signal at the same time. And what is the output? The output is who is speaking at which moment. So this is a generated result. And compare with the ground truth, they can estimate the accuracy. So that's the purpose served by the ADVI-AR dataset. And how do they compile the dataset? First, they need to create a voice and video recording system. So you can see this is the human head model. And on the left and the right ear, there are 2 microphones. And so the person here, first, this is doing a calibration work. It means when the camera is on top of the head, the person, it will hold a loudspeaker. The loudspeaker will play some white noise signal. And there is also a visual mark inside of the speaker, so that they will know at a moment when the speaker is at a certain region in the image frame. Then what is the audio signal the system will receive? After this training phase, then they will use the camera and the microphone system to capture videos when some students are played in the scenario. So this is an example. They have 3 different scenarios. The first one is the corner of the living room, and the second is a corner in a classroom, and the third is in the lab. So you can see this. The task is clear. It's a audio visual derivation problem. And they are not the first data set to address this problem. There are some existing data sets already. So AVDIR is published in 2017, and in the very, very early 2004, there is an AV16P3 dataset already. They address the same problem, but there are a few people. They will simultaneously moving and speaking. You want to recognize who speak at what moment. And there is another dataset called MVAD. But you see from this example, you can see in the MVAD dataset, all they are at the most 3 person. Okay, they always look at the camera and speak out something. So compare with the AVDI AR dataset, this is a relatively simple and straightforward. And also there's the AVASN dataset. Okay, there are two people simultaneously speaking, and one of them may move around. So if you want to do research for this problem, there are some existing methods. And then they proposed the AVDI-AR dataset because what? Okay, you can see from here. They provide more dynamic scenarios. Okay, and their speaking pattern or their movement pattern are more dynamic. It means the dataset is more challenging. If you can solve the existing method can solve this data set well, but cannot perform well in a new data set, then they need new algorithms or new methods to solve the problem in the new data sets. Okay, so there's statistics for the data set. There are 27 minutes in total, not very long, but you can see it will not be an easy problem. You have to develop the algorithm to solve it, right? Okay, so let's just an introduction to the two data sets. How will the two data sets used in the paper I want to show you today? Do they use the audio part? No, they only use the video part. Okay, say what is our input? A 4-second clip, right? Video clip. Do they use the audio part in the 4-second clip? No, they only use the visual part. Okay, right? Okay, so that's the proposed method in our paper. So let's see. This is a 4-second video part. And then they will employ a visual language model. And the visual language will get the input video clip and generate some paragraphs to describe the scenario in the video clip. And then, based on the description, they will hire another large language model. The large language model will generate some sentences the robot should speak out. So, but if you say, so, okay, that's all? No, that's not all. Their purpose is they want to train a small model to generate the same greeting sentences from the same email clip, 4-second clip video. Why do they want to do it? Because they want to, so let's go back to the title of this paper. They want to distill, okay, yeah. Okay. Yeah, here. This is a keyword. Distilling. Visual knowledge. Why do I do distill? Distill means, okay, let's go back to here. Okay. The teacher model is very large. The large language model is also large. Distill means they want to train or get a very small model, but they can do the same thing as the combination of the two huge models. So that's a distill. Why? Because this is robot. Suppose there is no powerful server, they only can use embedded devices on the robot. They want to achieve the same performance as the two huge models. Okay, so let's look at what is the large visual language model they use as a teacher. They use Lava 1 Vision 7B. Okay, And the large language model teacher is the Mistral 24B. And the student model is Lava 1 Vision 05.B. So here you can compare 7 billion parameters and 0.5 billion parameters. There are 14 times difference. Okay. So if you want to save energy to enable it on an embedded system and do the same thing. Okay, so this is very reasonable approach to do it. Okay, so what is Lava 1 Vision 7B? Any one of you used it before? Okay, so let me explain. Okay, I should say, why do they use this model? Okay, because there are some benchmark. Okay, see the number 88.9. Okay, on this benchmark, and 89.5 accuracy on this benchmark. All right. Okay, just keep it in mind. There are two benchmarks, and also there's some other candidates. That is VPG C7B model. Okay, so Lava 1 Vision 7B is better than this one in terms of this NLVR2 datasets. Okay, so let me explain what they are. So this is the NLVR2 benchmark, and there's a GitHub web page to show it. So this is a natural language visual reasoning task. Okay, it was published in ACL. ACL is the very important computational linguistic conference, and the paper, the dataset is not very new. It is published in 2019. Okay, so let's talk about what does the dataset provide. It's just like this one. So the 2 means the second version. The left hand side is the second version. And the left hand side is the first version, and the right hand side is the second version. So you can take a look and take this example. There is a yellow block as the top of a tile with exactly 3 blocks. So there are 1, 2, 3, 4 questions. Your vision model should answer true or false. So what is input? A image. So what is the output? True or false? Just like one. So look at the question again. Is there a tower with 3 blocks and the top blocks is yellow? Yes. So the answer of this first image is true. And for the second image, is there a tower with 3 blocks and the top blocks is yellow? No. So this is false. And this is yes, because this tower has the top yellow block. And this is false, because no tower has the top yellow block. Okay, so this is a visual language question. Give you an image, give you a question sentence. They are input. Use your algorithm to generate the correct answer, yes or no. So this is the dataset, NLVR1. And let's go to the second version. Okay, there are 2 images, right? And the question is, one image shows exactly 2 brown crowns in back-to-back caps on green foliage. Okay, so what's the major difference from the first version to the second version? First, the first version uses synthesized the image, and the second version uses the natural images. Okay, so this is the major difference. And the format of the is the same. you give, so see here, do you, so this is answer, true, false, true, false. So why this is true? Because, okay, do you see green foliage here? Yes, this is, in this image, there's a green foliage. And do you see two brown crowns? Yes, there are two brown crowns. Are they back to back? Yes, they are. So from this image, your algorithm should generate the answer true. And from this image, are they only two crowns? No, this is all single crowns, and they are more than 10 crowns. So no, so this is false. And from this, this is true. Why? Because the two crowns there, a pair of crowns on green foliages, yes. And here, false, because there are no clear two crowns back to back. So this, okay, is from this example image, you know what the dataset is designed for. They will test your models can understand the question and can understand the image. So yeah. And okay, so here the major difference just one is synthetic and that is real world, right? Okay, and this how many samples example are there? Around 92K and around 107K. So there are a lot of, because those images are easy to collect and the questions are easy to ask. Yeah. So what's the most difficult part? How to develop the algorithm to generate a high accuracy. So that's a very challenging question. Okay. But however, if you have a visual language model, so let's go back here. So that is the Lava VA1 Vision, the model. It is a visual language model. It can, when you use the model to extract the features from images, it should, okay, see, it can correctly answer 98.5% of those questions. So it is a very powerful model. Yeah. Okay, and let's see another dataset, the image DC dataset. It's a detailed caption bench, also called the CAP bench dataset. Okay, and this is a very, very new dataset. It was published in ICCVW 2005, just last year. Okay, and it is developed by ByteDance and the Lava team. Okay, so we see that's a Lava 1 vision, right? So let me explain what is a Lava. Lava stands for Large Language and Vision Assistant. This is a project first, collaborated with Microsoft Research, University of Wisconsin-Madison, and the University of Columbia University. And first, they published a paper, Visual Instruction Tuning in NeuralApps 2023. So that's why I say NIPS is a very important paper and highly related to computer vision. Because you see this, so this is an important, significant paper of computer vision, but published in NIPS. Right? So, okay, they released several visual language models. First is Lava 1.0, and then 1.5, and then next, and 1.6, and the MED for medical images. And 1.5 years later, One Vision. Okay, so let's take a break. Okay. All right, so let's go keep going on, and let's take a example. It will be very easy to understand what is the goal of the lava. Here, this is the image cropped from their paper. See, from this image, the question is, what is the unusual about this image? Okay, and their first release model, Lava 1.0, they generated this paragraph explaining why it is unusual. And in 2023, okay, there are some competitive visual language models. Chih-GPT-4, okay, it will generate this sentence. Will it say, okay, it point out what is the unusual part. There's a man ironing clothes on an ironing board attached to the roof of a moving taxi. Correctly? Yes, totally correct. But can it explain why it is unusual? No. So that's the difference. Okay, and there are blips. A blip too. Okay, yeah. And they are open flamingo. They can understand the image, but they cannot clearly explain why it is unusual. They just describe the image correctly. So it's enough. They want to help the users through languages. What is the important messages in this image? Okay, so that's why they call Lava. The last A is assistant. So okay. So let's see. So we see. So this is a lava, and finally they have a one vision. What does the one vision mean? Let's see. Okay. In the beginning, lava only deal with images. It makes sense, right? Because image is easy to understand, and single image. So their training set for the lava is a 3.2 million samples of single image. But can they deal with videos or multiple images? No. So the one vision means the model can not only deal with a single image input, but also multiple image input and video input. So this is their new dataset called One Vision dataset. It is there are 1.6 million samples and around one third videos, multiple images, and single images. Okay. So that's why they call one vision, because a single model can deal with 3 different types of input data. All of them are visual: single, multiple, video. So okay, for their video input, they have 6 datasets, and I will show you 2 of them. Okay. How do they train, or how do they evaluate their one vision model? So ActivityNet and Charade. So ActivityNet, there are several versions. The latest version is 1.3, released in 10 years ago, and there are 200 classes and sources from YouTube, totally 569 hours. Okay, they are their categories. Okay, let's take a look. So when you get the labels from ActivityNet, in fact, you will get a JSON file. And within the JSON file, you will have the link. And the link is from, it will tell you the duration of the video clip. And the label is layup drill in basketball. And from it start and end time point. So let's take a look. If we and let's go to the 20-second
rondo fake pass move,
okay,
part of the
so
fake,
here,
and then you go ahead and do what you want to do with the ball, whether it be pass, shoot, whatever. So here, I want to try to give a better demonstration of what's happening. When I'm dribbling and I pick it up there, I'm not even palming the ball here. As I zoom in, you will look at where I'm holding the ball. I'm holding it in between my forearm.
Okay, let's stop here, right? So you can see the activity net dataset is a combination of a lot of YouTube clips, and they create a label. However, as you can see, the dataset was released 10 years ago. And if the owner of those video clips removed their videos from YouTube, you cannot access it right now. So some links become invalid today. So that's a problem of ActivityNet. And let's see the charade dataset. Okay, this is the example of a charade dataset. Okay, let's take a look first. So you can see there's a person, another person come in and do something. All right, okay. So this is the first example. And the second example is this one. Okay, there is a person in her home do something. Okay, and actually there's a lot of labels. Okay. So this is very weird. It's a slip on the flower with a bit. Okay, however, the researcher, the charade project was sponsored by the Allen Foundation. And who is Allen? Allen is the co-founder of Microsoft. So he is super rich. Okay, and but he was sick at his late age, so he donated. And I remember he didn't get married. So he donated his fortune to the Allen Foundation, and the Allen Foundation support the project. So they give the foundation give them a lot of money to hire Emerald Mechanical Turkers. So all of the people you see here are Emerald Mechanical Turkers. The researchers provided the script, and the Turkers they follow the script to do the actions at their homes and ask their friends or families to take a cell phone or webcam to capture the video and upload to Emerald Mechanical Turk. And then the researchers also hire another group of Turkers to check whether the uploaded video matching those criteria, follow those script or have those action items. Okay, if all of them are satisfied, then they will approve the uploaded video and through the Emerald Mechanical Turk to pay those video uploaders. So, okay, if you have tons of money, you can do a lot of researches. All right, so here, okay. So now you have the sense of the charade data set and the ActivityNet data set, right? Okay, now let's talk about the Lava 1 vision, this architecture. Why can the model understand human language? Because it's based on the Chih-Yuan 2 large language model. Okay. And this is a logo of the Chih-Yuan. And Chih-Yuan has 3 sizes. The small one, 0.5 billion, 7B, and 72 billion. They are released by Alibaba in 2 years ago. And okay, this is the large language part. And there is also a vision part. They use the SIGLIP. Okay, SIGLIP is, do you know CLIP? I've heard of CLIP, right? SIGLIP is another approach to outperform CLIP. And we will see it later. Okay, so they have the vision encoder SIGLIP, and they have a language model Chih-Yuan. Combine them together so that the Lava 1 vision, using their training set, the Lava 1 vision 1.3 billion training samples to train the model. So that you have the architecture, you have the training data, you produce a new model that is a Llama 1 vision. Okay, so let's show something about the sigmoid. The sig means sigmoid loss. Okay. And it was published in ICCVW 2023, and OpenAI clip was published in ICNL 2021. So that's why I say ICNL is also important conference. Although it is machine learning, but clip it is so important computer vision paper, but it is not published in computer vision conference. It is published in ICNL. Okay, and sigmoid loss. What is sigmoid loss? It's a loss curve. Sigmoid function means the shape of the function look like an S character. So this is like it is a homogeneously increasing function. So they are a family of sigmoid functions. All of them are sigmoid functions. And in this paper, they use the log sigmoid function in this way. Okay. So pay attention to here. This is the xi times yz. So this is a paired term here. Okay. Once they have the paired inner product, they can use the log function to generate a loss value. What does it mean? If the inner product is very, very small, then the log value is very okay, let me see. If this is small value, then this will become 0. Okay, the loss function will be high, and if the inner product is large, then the loss value will be small. Okay, so let's go back to the clip first. So this is the image cropped from the clip. What does it mean? If you have a batch of image feature and a batch of text feature, you will compare them pair by pair. Okay, and you train your model to adjust your text encoder and the image encoder so that every text and image pair should generate high inner products. So that is the idea of clip. Okay. But however, how do they calculate the loss? They use the softmax loss. Okay, let's show you what is softmax loss. This is their equation. The softmax means you have a single image feature, and you have a bunch of text feature. You need to generate the inner product by the input text feature with all text feature. Then you expect this value is 1, and all of the others are 0 or -1. Okay, so you will so this is the first part, and for the second part is you have a single text feature, and you have a bunch of image feature. You will also generate their inner product. You will expect the one very high. The value of the input is very high. Say usually okay, and all of those other values are very small or toward the negative infinity, because through the softmax they will normalize to the a distribution between 0 and 1. Okay, so the softmax loss, there's nothing wrong, theoretically totally correct, but what is the improvement of this SIG paper? It used sigmoid loss to replace the softmax loss. So that what is the advantage? The advantage is they can improve the computational efficiency. Okay, let me explain why. Because when you compute the softmax loss, you need to put all of the bench features in the memory so that you can compare this image feature with those text features. Okay, but if you use sigmoid, because they are pair by pair comparison, you can split the batch of the text features into small chunks and then compute those chunks on different machines. So let's show this. If you use the softmax proposed by Clip, you need to put all of those text features and image features in a single machine. But if you use sigmoid, you can split the batch into 4 chunks and then run them on 4 machines. Okay, but however, you need to swap those chunks because you need the pair by pair comparison. So after the first round of the computation, this chunk of text feature will be swapped to the second machine, and the second one will swap to the third, and the third will to the first one. The first one, and then after the second round, they will swap again. How? So that's the advantage. So then, what will be the benefit if to introduce the modification? First, for the same, if you use Clip sigmoid loss, your batch size can be as large as 2K. But if you use the siglib, you can use a larger batch size. It will be 4K, 2 times larger. Okay, and also sigmoid loss is more robust than softmax for noise, and usually large text image data sets are highly noisy. So the sigmoid loss can generate a higher benchmark accuracy. So here you can see this is a clip, and this is a sig clip using the same model size and the same patch size. Okay. The patch size means given an image, you will split the image into patches, and then serialize those patches because this is a vision transformer architecture. Okay. So how many patches you will have, it depends on how many grids you will use to split the image. So there are different settings. Usually the page size is 16 by 16 pixels. So if you have an input image as large as 224 times 224, your page size usually is 196. But if you have a larger image, for example 332 times 332, then your page size will be slightly larger, for example 256. And if you use a smaller page size, not 60 by 16, instead it may be 12 by 12, then you will have more patches. Okay, this is just the hyperparameters for those models. And with the same model size and with the same patch size, siglib can generate a higher validation accuracy and for different tasks. For this is image 1K and this is cohort data sets. Okay, so that is the evidence supporting the claim sigmoid loss is more robust than softmax loss. And let's see another claim. Large-scale text image data sets are highly noisy. So let's take a look. This is image is cropped from a paper for blip. Blip means bootstraping your. It is the improvement of Clip. Okay, let me explain. Clip was released by OpenAI. They released the model, but OpenAI didn't release the training set. Okay, So other researchers, how do they solve the problem? They developed a open source text image dataset called Lion. And in the beginning, the Lion have around 1 billion image text pair. And they gradually increased the Lion to 5 billion image text pair. So how do they generate this? How do they get so much image text pair from internet? Right? Use search engine to Google to grab any kind of image links. And if there is a label on the link, okay, they also grab it. Okay, however, you can see from this image, so the label grabbed from the internet is a week spent at our rented bench house in Sandbridge. Does it match the image? No. So that's a problem. When they use the internet as a source of the image text pair, there are a lot of mistakes. So that's the original text. That's what a sign says over the door. Does it make sense of? Is it correctly describe this image? No. Okay, so that's why they claim. I say they is the authors of the blip paper. They claim, okay, because the data set, the training set is too noisy. So they need to bootstrap. What do you mean to bootstrap? It means generate pseudo labels by their own self. So this is the pseudo label or pseudo sentences describing this image by their blip method. So from this image, they generate a label, an outdoor walkway on a grass-covered hill. Okay, it makes sense. So they improve the training first in terms of the text description, then they train a visual language encoder, just like a clip. Okay, so I just want to show these images to support the claim. Large-scale text image data sets are often highly noisy. So that's the reason why they show us sigmoid loss is more robust than the softmax loss. Okay. But however, there's a following question. If so, then why the clip developed by the OpenAI is so useful? Because, okay, because OpenAI doesn't release their dataset, so we don't know. We only can guess. Many scholars guess because the training set of the clip is well tuned. They may hide a lot of humans to correctly generate those labels. All right, okay, let's go back to our paper. So you currently know what is the LLaVA1 vision, okay? And it is a powerful, useful, effective vision language model. All right, okay, so let's take a look of its prompt. Okay, it will give the LLaVA1 vision 7B a prompt, describe the video in detail, etc. Okay, so the purpose is, okay, because LLaVA1 vision can understand the input image or input images or videos, then it will generate the description. And then the second step is the large language prompt is this one. Once you have the description in detail, then you ask the teachers to generate the sentences the robot should speak out. So the prompt is, you are a social robot that has to assist and play with people, and then following those instructions to generate the sentence. Okay, so it makes sense. And the format TTS means text-to-speech. Okay, this is a very common command for a robot. Yeah. Okay, and the second part, what is the large language model Mistral 24B? Okay. They use it, but why do they choose it? Well, it is developed by the Mistral AI. It's a French AI startup. Okay, founded 3 years ago, and by former Meta and Google DeepMind researchers. And okay, the company is very open. They often release their weights, so this is useful for researcher. And there are for this model, it is released 14 months ago, because it is January 2025, and why do they choose 24 billion? Because the model can run on a single 4090 GPU, because the VRAM size of 4090 is 24B. So they are very, very friendly. Okay, so there are some other versions. There are 3.1 and 3.2. There are some improvement. Okay, there are comparison. Mistral 24B and the Q1 272B. Okay, which one is better? Okay, there is a metric called LN Arena score, and Mistral get 1268, and the Q1 272B get 1258. So this is better. Okay, and the model is smaller, but the performance is better. So it is a very useful model. And there's a giant model, DeepSeek V3. It has 671 billion parameters. And of course, its score is higher, 1396. But the domain expert doesn't feel significant difference. Okay, so what does it mean? Okay, so Mistral 24 is a very good balance in terms of its output sentence quality and its computational efficiency. You can run it on a single 4090 GPU. It is a miracle. Okay, so what is the LN Arena score? Let's take a look. It looks nice. It's just a website service. Okay, and you can go there by your own, but let me show you. When you go there, and you can choose which model will compete with another model. So I choose. One is Cloud Opus 4.6, and another is Gemini 3.1 Pro. And you can key in your question. So I key in a question. Who is the president of CGU? Okay, yeah. So CGU. And you can see there the Cloud Opus 3.9, it generated the response. The president of CGU is Len Jessup. So it doesn't know CGU is our school. It thought CGU is Claremont Graduate University, right? And Gemini 3.1, it considers two CGU. One is our university, and another is the Claremont Graduate University at California. And it shows us, okay, Lei Jessup is the president of that university, and Dr. Minzer Tang is the president of our university. So which one is better? It's up to the user, right? Okay, and then you, as a user, you can choose A is better, or both of them are good, or both of them are bad, or B is better. So what is this? Users will rank or upgrade the generated responses of two large language models. Okay, so they collect the user feedbacks, and they will generate the score. So that's why Mistral 24B, its arena score is higher than Q12 24B, 72B. What does it mean? Many users, or most users, on average, think Mistral 24B is better. Its score is higher. Okay. So that's the reason why. Okay, and so it makes sense. They choose Mistral 24B. And the latest question is, why do they need to train the lava, the small model? Okay, so they use this device, JSON, AGX or RIM. So this is I have the same device in my office, just like this one. Okay, so they use this machine to validate their experiment results. So let's show some specs of this machine. Well, it was released 3 years ago, and there are 2 editions, 32 gig and 64 gig. And then it is a shared memory by the GPU and CPU. And this CPU is ARM Cortex. There are 8 cores. And their GPU is the GB10B. And the performance is 275 TOPS. Okay, TOPS is the tera operations per second. So, and okay, the power consumption is 15 to 60 watt. And the price, it is 75K to 83K per unit. Okay, so this one. And I need to tell you, you can borrow it. That is the property of our department. All students can borrow it. Yeah. Okay. But there are some drawbacks. First, it's an easy burn. Okay. So I heard from other researchers, they burned JSON Onyx. And I thought, oh, they burned 80K Newton dollars. Okay. And this is the inference speed. When they use the machine, and if they expect that the output sentence has 32 tokens, then they need only 2 seconds to generate. Okay, this is the best performance. And if the length is longer, then they need more time. But however, 2 seconds, I think is acceptable. Only acceptable, not very good, yeah, but acceptable. And this is their experiment. They train. They can use their teachers to generate a lot of responses, right? And when they have those responses, they train the student model. And they, at the most, train only 1,500 steps. So this is from the beginning to the 1,500 steps. They use different models to test the result. So you can see all of them are lava one vision, and all of them are the 0.5 billion model. The only difference is the T. T means the number of frames extracted by the 4-second clips. So we say lava one vision can handle multiple input image, right? So from the 4-second video clip, they can extract just 1 frame, or 4 frame, or 8 frame, or 16 frame through the uniform temporal sampling. Okay, just for the 4 seconds. And suppose the frame per second is 30, then there will be 120 frames, right? From the 120 frames, sample 16 frames uniformly, that's all. And then they compare how many frames will be most efficient. So this is the validation set. And the best one is the orange one, it is the 8 frames. And the second one is the green one is 4 frames. Okay. But however, in the test set, the best one is the 1 single frame. Okay. Right. Okay. So you see this. So this is the numeric quantitative evaluation, and this is a qualitative evaluation. They ask human subjects to look at same video clip and answer the 5 questions. So the 5 questions: do you think the generated sentence is pertinent to the context of the video? Yeah. So something like that. Okay, so there are 5 different questions, and just let's take a look because we will see something later. The second is the generated sentence synthetically correct? Is the generated sentence semantically correct? Do you think the sentence is appropriated to attract, see here, attract the user's attention. Because this is a social bot, it will do the proactive behavior. They want to attract the human attention. How do you rate the overall quality of the sentence? Okay, and that's their experiment results. They hired 19 participants and test 55 unique video clips. And overall, they collected 298 questionnaires. Okay, so this is 5 questions. And which one is the best? Which one gets the high score? Q2 and Q3. And let's take a Q2 and Q3. Okay. Q2 is the generic sentence syntactically correct, and is the generated sentence semantically correct. So when they have a high score in the 2 questions, what does it mean? It means, okay, let's jump in. It means the model is effective. They can understand the input images correctly and generate a correct sentence. At Q1 and Q2, the score is very high. What does this mean? It means, although the model understands the C, the generated sentence cannot attract those people in the video. Okay, so that is a way to improve. And last question, QF, it means 4.1, it means just okay. Okay, they also show the Chrome batch alpha. Okay, so let me explain it. So there are 5 questions, right? They want to know, are the 5 questions consistent? So this is the statistical index. If the, okay, so the sigma x means the variance of all scores. And the sigma y means for a specific question, what is its variance? So they will do the average for the 5 questions. If the alpha is greater than 0.7, it means it is significantly consistent, and their alpha is 0.3. It means, okay, their qualitative evaluation, the 5 questions are sufficiently significant. All right, so that's all of my slides. So now we will go to the discussion session. Okay, first, let's go back to here. How to read a paper? Yeah, okay. So let me go through one of them. Okay, what is the problem definition? Okay, I know being quiet is the habit of our university. No, for most of people. So let's go through it. Okay, Jared. Yeah, first question. What is the problem definition? Yes. I just want to know, do you know the problem definition of this paper? No, okay. If so, then let's ask Ken. So what's the problem definition of this paper?
They want to make some model that fits on the robot.
Mm-hmm.
Model. So we try the distillation technique to
Good. Okay, very good. And the second question, what is the input and output? Nino, yeah, what is the input and output of this paper or this method?
The input basically are the videos that they during the training,
Mm-hmm.
and the output is basically which model is better compared to the other models.
Well, no, the output is the sentence, yeah, of the model. Yeah, okay. All right, okay. Let's skip the related work. Okay, so what is the innovation proposed in this paper? Okay, and Wenceslas, sorry, how to spell it? Wenceslas. Okay, yeah, please. What is the innovation proposed in this paper?
Well, I think the innovation that was proposed in this paper is that although there were a lot of models presented in the Java, they were, or the author is seeking, since the technology is, let's say, evolving, there are images and videos that cannot be singly identified in one how do you call this in one analysis. So with the newer methods like the one architecture, one one architecture, it combines the picture and videos at the same time, identifying what's on the.
Never mind. Okay, this is discussion. Yes, please. Yeah.
I think the innovation of this paper is that they want to build the large model that can embed it into the robot, and by apply the distillation learning approach, yeah, and they will train based on large model and then build a student model to learn.
Yes. Okay. That's true. So if I want to say, I would say they develop a low cost method, very, very low cost. They don't need to hire any humans. They just use two models so that they can train a small model. Very cheap way, yeah, to do it. Okay, so there's an innovation. Right? Okay, so is the experimental validation convincing? Okay, and Wu, yes.
So the validation they have is by comparing all those different model they use. So they able to get those kind of data, which one is better, which model is better, which one is not good in performing. So they get they get the data which model they're going to use.
Okay, so I should ask, if you are a reviewer of this paper, do you buy their submission?
Well, based from their observation or of the data they gathered, I believe they have those.
Okay.
And probably if you're going to do those things, then they help you which one you're going to implement.
Okay, yeah. So do you have any critique for their experimental results? I should say, if you were a reviewer of this ICCV workshop, yeah, when you review their paper, okay,
it is convincing.
For you?
Yeah.
Okay, fine.
With all those data they gather and presented in this paper.
Okay, yeah.
With the tests they've done.
Okay.
It's convincing.
Yeah, basically, yes. I should say, when you read papers from those published, actually, because all of them have been published, there are at least 3 reviewers and 1 area chairs read those papers. So basically, it is convincing sufficiently. Otherwise, they won't be accepted. But however, you can still think another question: how to make the experiment result more convincing? Okay, what folks? Yeah.
I think it's when they show the data, the graphs and the result they have, the experiment. For me, it's convincing that the solution they have is the paper they present is really correct and concise.
Okay, so how to make it more convincing? You might just think it. While you read your own paper, think about it. Okay, now last question. Do the authors release their code? And I should not ask you here. Okay. And okay, I should say, actually no, they don't release it. And can you reproduce the results? I think yes, because the hardware requirement is very low. You just need a 4090 GPU. You can try it. At least you can try it. Okay. And okay, no, what are the limitations? So let's see, Ting Wei. Yes, please. Please.
Can I use Chinese?
No, you only can use English. No matter how good or poor your English is.
It maybe has some occlusions or some other people hide it. Is that a limitation?
Occlusion. Well, in fact, okay, let me show you what is the occlusion I see. Okay, from limitation I see they only train on two data sets, right? The Moomer and let's go back to the slides. Yeah, yes, okay. And so I think that is a limitation. I should not say what will happen if they train other data sets. Okay, if you want to make the experiment more convincing, you should try more data sets. Okay, but however, and you can see, let's go back to the slide first. Yes. This is a Moomer, right? Okay. And they only use the video part. And yeah, okay. And however, you need to find data sets that are designed. And for this one, for this data set, okay, this data is not designed for robotic interaction, right? Because this data set is designed for audio-visual diarization. Okay, so could you find another data set that is designed for a social robot? Moomer is, right? Moomer is. But is there another additional data set designed for social robot? If you can find, use it to validate. It will make your experimental result more convincing. And the limitation here is they only use the two data set. And for this data set is not captured in the real scenario. This data set is compiled in a lab. So I think that's a limitation. If you, yeah.
So the limitation is the data set that you have.
Yeah, that's right. Yeah, that's one of them. Okay, and another one of them, I would say, they only use visual data. Could they use audio data together? You say they use the visual data to generate a sentence, right? But so do the robot understand what those participants are talking about? If the robot can know the sentences those participants are talking about, will the generated sentence is more attractive? All right. Okay. So that's all of our slide course today. Okay. And yeah, please just pick your own papers, and we will let you present your own papers from next week. And let me know it earlier because I also need to read your papers.
You already provided us the list of the papers. We can get some.
No, you find your own paper. I show you how to find the papers today, right?
Is there? Okay. I don't know. Maybe I have no idea where to.
Okay.
Find some kind
Yeah.
of
What is your own research topic?
I still don't have any idea what's to be my research topic.
All right. Okay. I have a suggestion for you. Pick up the oral paper. Oral is the best paper from the top conferences within 1 year. And let me know. Okay. And I will use a random number to create a list so that I will release the list to you soon through Teams. And everybody in a Teams chat, Teams channel, right? You received my messages. Okay. Thank you all. This is all of the today's course.